Hi folks, Mr. Long here. This is part 2 of a screencast on determining the x values that are part of the critical values, so when the slope is 0 or when the slope is undefined. And these screencasts will focus on use of the product rule. Okay, so we've got a function here, x times root of x minus 3. Now this is one that we did graph in the rough sketches, and was a really weird one. If you remember, it looked like this. So it actually just went like that, something like that, and that's because the domain for this one, that x minus 3 always has to be greater than or equal to 0, right? Or otherwise you'd get a negative under the square root sign. So this graph starts at x equals 3. It doesn't exist to the left of x equals 3. So we're going to get an answer here at the end that's not in the domain, and that's good. It's a good opportunity to go through and see. It's just like if you remember logarithms, sometimes you would get a solution to an equation with logs, and it wouldn't actually fit in the domain. Okay, so same sort of thing here. All right, so let's get going. So we need to get the derivative of this right here, x times root of x minus 3. Well, one thing I notice is there's square root of x minus 3. I know I'm going to need a chain rule for that. So what I do is I go over here and I just do it separately, the chain rule for that one. So, and that's, in the terms of the product rule, the first thing is going to be a, the second factor will be b. So this is what we're doing here is we're getting b prime. So I need to get the derivative of x minus 3 to the 1/2. Square root's 1/2. Exponent 1/2. So I set u being the inside, x minus 3, and then the derivative du by dx is 1. Then the outside function becomes u to the 1/2, and that becomes 1/2 u to the negative 1/2. Now, with the product rule, so if you remember in the previous video, I said if there's no product rule, you should always take that u to the negative 1/2 and make it a positive exponent. Well, if you're going to use the product rule, if you're using the product rule, you can leave that negative there, or you can bring it to the bottom. It depends on the strategy that you use to simplify your equation for solving. You'll see that on the next page. Okay, so we've done that. Now, really, do you need to use the chain rule for this? Well, like to go through all this, showing all the work for the chain rule. Let's think about this for a second. What's the inside derivative of that going to be anyway? Well, it's just going to be 1. So really, it's going to be 1 multiplied by the outside derivative. Why wouldn't I just write, since I know I'm going to multiply by 1, why wouldn't I just go to that, right? So for me, if I see that as the function, I would immediately write the derivative as 1/2 x minus 3. Sorry, I'm on my computer rather than my iPad, so it's a little slow to write, to the negative 1/2, right? So that would be my approach. I'm not saying that you have to do it that way, but it's a lot faster to do it that way because, again, the inside derivative is 1. Okay, so now what we do is, now that we know that the derivative of x minus 3 to the 1/2, now we can use the product rule. A and b, so it's a prime b plus ab prime. And remember that we write it in the same sequence here, so since that's a prime b, I write a prime here, I write b prime here, or b here, then a multiplied by b prime comes next. Now, what we do is we write a prime, as I said, a, b, and b prime, but of course I write down a first. The derivative of a is 1. Then I have b right here, and I write down the derivative of b. Notice that it was 1 over 2 u to the negative 1/2. What does that become? Well, I replace u with x minus 3. Do I need that 1 out there? No, I don't. So instead of saying multiplying by 1/2, I just divide by 2 because that's equivalent. So now what I need to do is to put it all together in a single equation. A prime b plus ab prime, which we've done right here, x minus 3 to the 1/2, 1 times x minus 3 to the 1/2, plus x multiplied by this right here, okay, and that all equals 0 because if the tangent slope is 0, I have a max or a min or a saddle point. Whoops, went too far there. There we go. So we're going to have two approaches here. We're actually going to have an approach where we're going to simplify by factoring, and then another one where we simplify by getting a common denominator. This is the strategy I had you practice maybe a week ago. Yeah, it was last week that we worked on this. And so again, it's exactly the same as what you were doing last week. So I've just rewritten out the same last line from the previous page. So we're going to solve this equation by common factoring. So what is the common factor? Remember, the greatest common factor is the base, the common base. X minus 3 and x minus 3 are bases. Bases have exponents on them, right? And then the greatest common factor is the least exponent of the common base. So negative 1/2 is the least exponent. So what I do then is this becomes my common factor. When I'm factoring, that means I'm dividing by that factor. So I have to go x minus 3 to the 1/2 divided by x minus 3 to the negative 1/2. 1/2 minus negative 1/2 is just 1. So I just have x minus 3. And then I'm dividing x minus 3 to the 1/2. Negative 1/2 divided by x minus 3 to the 1/2. When I divide two things that are the same, the answer is 1. So the only thing I have left is this x over 2. And that's that x over 2. So now I have x plus x over 2. Well, that's 1 whole plus a half. That's 3 halves. So I've got 3 halves here minus 3. Now that's negative 1/2, so I can bring that down here to the bottom and make it a positive exponent. And now I just go ahead and I go into my solving. I'll just zoom in on that a bit. So I let f prime be 0, and that's where the tangent slope will be 0. So when is a derivative worth 0? Or sorry, when is a fraction worth 0? When the top is worth 0. So I solve that equation, 3x over 2 minus 3 equals 0. How would have I done that? I would have added 3 to both sides, and then I would have divided both sides by 3 and multiplied by 2. Okay? Or you could just say 1.5x minus 3 and divide by 1.5. So x equals 2 is a location where the tangent slope should be 0. Except remember, x equals 2 is not in the domain for this curve. So that's kind of a fake critical value. Now, when does f prime not exist? Well, anytime I get a 0 in the denominator. So if x minus 3 is 0, then f prime does not exist at x equals 3. And that does work because that ends up being a vertical tangent there, right? It's a one-sided cusp there, so that ends up being a critical value. All right, let's take a look at the other side now. And we're going to simplify this with the common denominator. Okay, so this is a different strategy. So let's look at this. So if you're using the, if you're common factoring, you leave it as a negative exponent. Okay, anything that has a negative exponent, you leave it with a negative exponent. If you're going to get a common denominator, you need to have denominators. So you take this right here and you put it into a denominator. So that's what we've got here. So now we're going to get a common denominator. Well, that's actually pretty straightforward because the only thing that's in a denominator is this. So how do I get a common denominator? You've been doing that since grade 11. Algebraically, you just multiply the top and the bottom by the same thing for where you need to change the denominator. So I've got x minus 3 to the 1/2. Well, that means I have to multiply the top and the bottom by the same thing because in effect, I'm multiplying by 1. So I'm not really changing the quantity at all. Now, what's really nice here is anytime you're working with these rational exponents, that when you do this, because of the power rule of subtracting by 1, this multiplied by this is always going to give you an exponent of 1. X minus 3 to the 1/2 multiplied by x minus 3 to the 1/2. And then I've got the 2 in there as well, of course. So really what I've got is two groups of x minus 3 plus this x over here, and then I have a common denominator. And so what I can do now is I can solve this equation. So that's going to be 2 times x multiplied or added to 2 times negative 3. So that's 2x minus 6 plus this x here. That becomes 3x minus 6 equals 0, x equals 2. And again, we said that's not in the domain. f prime does not exist. If the denominator is worth 0, the denominator is worth 0 at x equals 3. Okay, at x equals 3. So, and then at this point, you're done this part. Now you have to make your table, substitute those x values into the formula, the original formula, to get all the y values and pick out your absolute max and your absolute min. Okay, so again, two different approaches, you're going to get the same results. So you can simplify with common factoring, or you can simplify with a common denominator. I can tell you that most commonly the approach is to factor, and I was trying to think through why do people always factor rather than get a common denominator. And I think it's because of maybe the quotient rule when you do this, but you almost never see this getting a common denominator, but I actually find getting the common denominator easier. It looks like there's a little bit more work, but I find that you get rid of, by getting a common denominator, you're not going to end up with fractions in the numerator at all. So anyway, your choice. You can simplify by factoring or simplify by a common denominator. All right, let's move on, and we've got one more to do. So this one is like 13, 14, 15, and 16. And with this one, we're going to be doing again, a product rule with a quotient rule. And I think there might be one or two questions that have a function inside of it that you have to differentiate. So what I want to do here is I want to see if we can skip all of this stuff here, just go to the answer. Let's look at this. So that's x minus 5 to the 2/3. So what's the inside derivative? It's just 1. Okay, so it's just going to stay as x minus 5. There's not going to be a number out here. Now, it's exponent of 2/3. Sorry, there's not going to be a multiple here. Like, we're not going to have to differentiate the inside here to generate something because the derivative of this is 1. So the 2/3 is going to come to the front, and then this 2/3 is going to be reduced by 1. So that's going to be negative 1/3. So in fact, really what I can do is, if you look, b prime, I can just go directly to do that. If you want to do all the work that, with the chain rule, you can, but you're probably going to spend a lot less time if you go here directly to here. So again, 2/3 comes to the front, and then your inside derivative is 1, so you're multiplying by 1, and then reduce 2/3 by 1. 2/3 subtract 1, which is 2/3 subtract 3/3. So, and what did we say about if we're going to simplify with a common denominator, we want to make a denominator. If we're going to simplify with a common factor, we want to leave this as a negative exponent. Okay, so then I write it in the same manner, a prime b because of a prime b, and then a b prime because of a b prime. So then this multiplies with this, a prime b, and that comes down to right there. And then, so 1 times x minus 5 to the 2/3, and then I'm multiplying x by this right here. So when I multiply x by 2/3 x minus 5 to the negative 1/3, remember that I'm going to take that coefficient of 2/3. So a mistake a lot of people, it's not a mistake, but it just doesn't look right, and you're gonna have to do more work later. A lot of people will do x times 2/3 times this. You might as well write it as 2/3 x times x minus 5 to the negative 1/3. So that's your derivative, right? You're totally done your derivative there. And after that, it's just simplifying. So the calculus part of this question is already over. So let's take a look at the next part. So once again, we're going to solve by common factoring, but we're also going to solve with a common denominator. So I'll zoom in on this a bit so we can see. So that's just the original line from the previous page. So now we recognize that our common denominator is, so it has to have the same base. So there's a base of x minus 5, there's a base of x minus 5. And then it's the least exponent. Negative 1/3 is the least exponent. So there's our greatest common factor. So what I do is I write the greatest common factor out at the front, and then remember that I'm dividing now. So I'm taking each term and dividing by the greatest common factor. So it's x minus 5 to the 2/3 divided by x minus 5 to the negative 1/3. What is 2/3 minus negative 1/3? Well, that's just 2/3 plus 1/3. So it's x minus 1 to the exponent, x minus 5 to the exponent of 1. And then here, I'm dividing x minus 5 to the negative 1/3 divided by x minus 5 to the negative 1/3. Well, that's just 1 because I'm dividing two things that are the same. So the only thing that's left over is 2/3 of x. Okay, so what I then do is, and I would encourage you to do this, is I then take this right here and I write it in the denominator. Okay, so it's going to come down here into the denominator there. So I've got x minus 5 plus 2/3 x. So I have to take 1x and add 2/3 of an x. That gives me 5/3 of an x. So I have 5/3 of an x minus 5. So I want to set f prime equal to 0 to figure out if I have a max or a min. And I do that. When I solve that equation, I'll get x equals 3. I'm not going to show the steps of solving that equation. I'm very confident that you can do that. And so then x equals 3 is one of the numbers that will appear in your table. So you'll have x equals 3, and then you'll figure out the y value from the original function. Then we have to figure out where does f prime not exist. Because when f prime doesn't exist, you can get these features, which can also cause maximums and minimums. So the bottom is 0 when x equals 5. So that's using a factoring strategy. What about the common denominator strategy? That's over here. So with the common denominator strategy, I actually write this x minus 5 to the 1/3 in the denominator instead of having it as a negative exponent. So what is the common denominator? Well, there is no denominator on this one over here, so it's pretty straightforward. It has to be this right here. So what am I going to multiply that first term by? By 1, which means the common denominator, the LCD divided by the LCD, right? So, and again, here's what's nice. That's 2/3 and that's 1/3. It's always going to add to 1 as long as you've done your derivative correctly. So I've got a 3 here multiplied by x minus 5 to the 1/3 and x minus 5 to the 2/3. When we multiply like bases, we add the exponents. 2/3 plus 1/3 is 1 whole. So I'll mark that there. So I've got 3 groups of x minus 5 plus 2 x's, and then I have that common denominator there in the bottom. And now it's quite easy to solve. 3 times x is 3x, 3 times negative 5 is negative 15, 3x minus 15 plus 2x from there equals 0, and that's going to work out to 5x minus 15 equals 0, and then you're going to get x equals 3. And that is in the domain for this one, so that's where you have a max or a min. And then we want to figure out where there could be a one-sided or two-sided cusp or a cube root type of graph. So x minus 5 equals 0 when x equals 5. So, and remember that what that means is there's a vertical asymptote on the derivative, not on the original function, but on the derivative. So that works out, f prime does not exist when x equals 5. So that's when you can get your, for example, a two-sided cusp or a one-sided cusp, or that cube root type function that looks like this, and it has a vertical tangent right there. Okay, folks, so that's all the calculus portion. What you should do then is to do so the process is to do your rough sketch, then you do the calculus work, and then you make your table from the left endpoint, and then you figure out you put in any of the critical values that occur between the left endpoint and the right endpoint of the interval, and then you figure out the y value for all of those x values. And then you pick out the highest x value and the lowest, or sorry, the highest y value and the lowest y value, and that gives you your absolute max and min on that interval. Okay, folks, so good luck. I know that I've left you a lot of work. I would just do the questions that I'm suggesting after each video. So, you know, once you do this one, once you look at this video here and understand it, I would encourage you to try 13 and 14 for sure. 15 and 16 and 17 too. 17, they're a little bit tougher. Those are, I would say, those are more optional if you're planning on taking a pretty demanding math class in university next year. You need to do everything. But if you know if you're taking typically, yeah, so if you're going to be in engineering calculus, or you're taking physics or chemistry in university, then or you're taking math for like an honors math program, you definitely want to do the harder questions. Okay, so I'll leave you with that, and good luck in doing the rest of your questions.